In this video, we're going to use Gaussian elimination method to find x, y, and z of these linear simultaneous equations, and we are going to go through these 3 steps. So the first step is to form the augmented matrix from the 3 equations. So we just form the matrix. So first of all, we have to write the coefficients of x in the first column, then the coefficient of y in the second column, the coefficient of z in the third column, and then our augmented column will be formed from the constant in the right hand side. So for the x, I have 1, then I have 1, then I have 2 for the third equation. Then for the y, I have 1 minus 1, then 1. Then for the z, I have minus 1, then 2, then 1. So my augmented, I will separate it with a straight line. Then I will write my constant. So I have 7, then 3, then 9. So this is my augmented matrix. So the second step is to make coefficient of x in row 2 and row 3 to be 0. So that is, I want to make this 1 to be 0 and this 2 to be 0 with respect to row 1. So my row 1 will remain the same. So I will have 1, 1, minus 1, and 7. So this one will remain the same. So I need to form a transformation formula for row 2 and a transformation formula for row 3. So to do so, I'm going to do the transformation with respect to row 1. So for row 2, the transformation formula will be R2 plus K, which is a term I need to find, times R1. So I want to find a formula such that if I apply it, my R2 will be 0. So I'll write 0. So my R2 is just 1. So I have 1, then plus K, and my R1 is 1. So I have K will just be equal to minus 1. So for this formula, for R2, I will just have R2 minus R1 because my K is minus 1. So what of the transformation formula for row 3? So for row 3 also I have R3 plus K times R1 because it is with respect to row 1 and I want it to be 0. So my row 3 for x is just 2, then plus K, then times R1 is also 1. So I have my K to be equal to minus 2. So it means the transformation formula for row 3 will just be R3 minus 2 R1. So now I just have to apply the formula. So if you look clearly, for the first element here, I have R2 minus R1 is just 1 minus 1, which is 0. So I will just put 0 here. For the second element, I will have minus 1 minus 1, so it will be minus 2. So I'll have minus 2 here. For the third element here, I will have 2 minus 1, which is just 3. So I'll have 3 here. For the augmented element, I will just have 3, which is this 3, then minus 7, which will give me minus 4. So I will have minus 4 here. I will now form the elements of my third row. So I need to use this formula. So I just have 2 minus 2 into 1, which will give me 0. So I'll have 0 here. For the second element here, I will just have 1 minus 2 into 1. So I'll just have minus 1. So I have minus 1 here. Then for the third element, I will have 1 minus 2 into minus 1, which will give me 3. So I'll have 3 here. So for the augmented element, I will just have 9 minus 2 into 7. So it will just be 9 minus 14, which is minus 5. So I will have minus 5 here. So the third step is to make the coefficient of y in row 3 0 with respect to row 2. So this is now my new augmented matrix. So now I'm going to do my transformation with respect to row 2. So row 1 and row 2 will remain the same. So I just have 1, 1 minus 1, and then 7, then 0, minus 2, 3, and minus 4. So I will now change my row 3. So I'm trying to make this element to be 0. So my transformation now is with respect to row 2. So I will just have R3 plus K R2 is 0. So I'm targeting this part. So it means I have minus 1 plus K minus 2 is 0. So it means I have minus 2K is just 1. So it means my K will just be minus 1 over 2. So my transformation will just be R3, my K is minus 1 over 2. So I will have minus 1 over 2, then times R2. So now I just need to find the elements. So from here, you can see if I apply, I will just have 0 minus 1 over 2 times 0, which is just 0. So I'll have 0. Then I have minus 1 over 2 into minus 2 is just, I have minus 1. This one, 2 over 2 is 1. Negative, negative, positive, plus 1. So this will be 0. So I'll have 0 here. Then I will have 3 here, which is 3 minus 1 over 2 into 3. So if you simplify, you'll end up with 3 over 2. So I will just have 3 over 2 here. So for the final element, I will have minus 5, then minus 1 over 2 into minus 4. So if you simplify, I have 2 here, minus 5 plus 2, I will end up with minus 3. So I'll have minus 3 here. So my fourth step is to reconstruct my equations from this augmented matrix. So if you look at the first equation, I will just have x, then plus y minus z is just equal to 7. Then for the second equation, so let me call this A. So for the V equation, I will just have minus 2y plus 3z is equal to minus 4. Then my final equation will just be 3 over 2z is equal to minus 3, and this is my C. So for my step 5, I just need to compute my unknowns from these equations. So from C, I know I have 3 over 2z to be minus 3. So it means my 3z will just be minus 6. And it means my z is just minus 6 over 3. So my z is just minus 2. So substituting z into my equation B. So put z in B. So I'll just have minus 2y plus 3 minus 2 is just minus 4. So it means I have minus 2y will just be minus 4 plus 6, which is just 2. So it means my y is 2 over minus 2, which is minus 1. So finally, I just have to put y and x in A. So it means I have x minus 1, then minus 2 is just 7. So it means I have x minus 1 plus 2. I have plus 1 is equal to 7. So it means my x is just 7 minus 1, which is 6. So if you want to learn how to solve the same equations using Cramer's rule, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.